Hello and welcome to CompuScholar's Professional Development webinar for January 2019. Today we're going to be introducing our Python programming course, and in particular we're going to discuss how it solves a couple of major teacher challenges. My name is Chris Just. I'm the president of CompuScholar. I've spent many years as a software engineer as well as a number of additional years developing curriculum for the middle and high school market. I'm always happy to chat with you about anything that's on your mind, so you're welcome to email me at chris.just@compuscholar.com. So today again we're going to be talking about our Python programming course, and in particular we want to discuss how it makes your life easier as a teacher with regards to software installation and project grading. And of course we'll do a demonstration of the actual course at the end. So we know that local software installation can sometimes be a pain. So maybe some of these problems are familiar to you if you've ever had to install a development environment on your local lab computers. You might have some intense discussions with your IT staff about whether or not it's permitted and that sort of thing and how to actually get the software installed. You may have run into some account permissions with your student lab accounts that made things difficult to run or execute. You may have had to worry about licensing issues. Even free software sometimes requires email addresses or some other form of free licensing. And your students are generally tied to your lab unless they have a computer at home and they're able to install that development environment at home. So our solution in our new Python programming course is to develop an in-browser Python engine so students can type code, run code, and see the results directly in their web browser. So you never have to actually install anything locally with our Python programming course unless you want to. Now, as a computer science teacher, you've doubtless spent many hours grading student projects, so you have to manage the project file submissions coming to you. You've got to actually look at those source files to see what the student's written, go ahead and build and run the code and try and verify the output manually, and then figure out what sort of grade you want to apply to that project. And of course, even with a small class, that can be time consuming, and as you grow to multiple class sections, that can take a very large chunk out of your day. So our Python programming solution is to actually support projects being submitted online, and those projects are auto-graded by our system. So the auto-grading system will actually inspect the source code itself looking for key markers, as well as verify the student output. So with a click of a button, you can bypass all of the grading worries that you're used to hassling with in a computer science course. So our Python programming course is brand new. It is currently a single semester course that is geared as an introductory programming class for kids that have no prior experience with computer programming. So it's very easy. It is suitable for a wide grade range, anywhere from 6th up through 12th grade as that introductory programming course, and we're really excited about it. So without further ado, let's switch over to our system and we'll give you a little tour. Alright, we're logged into our Python programming course with a student account, and you can see it has all of the typical features of a standard CompuScholar course. With the student menu, we have instructional videos and lesson text and quiz for every lesson. We've got hands-on activities and the chapter exam. So the magic really starts happening in the lesson text. So let's take a look at an example. Okay, we're looking at an example lesson. And here's an example of our in-browser Python engine. In places where you might normally expect to see just static code examples, we have this Try It Now box where the code in here is actually live code that you can type, modify, and execute. So we can run this code as is, for example. We'll actually go off, execute the code, and then show you the results here in the browser. And the student can come in here and modify the code and run it again and see the different results. So this in-browser engine is very powerful. It allows the students to experiment directly here in the web browser without having to go out to a locally installed development environment on a computer. So as you can imagine, this allows students to experiment with the code from any web browser on any sort of device, like a tablet or even a smartphone, so they're not necessarily tied to a desktop computer. I'm going to scroll on down to the bottom. And you're probably familiar with our Work With Me exercises, so these blue sections are found at the end of most of our lessons, and these are intended as hands-on exercises that the students can do directly after reading the lesson text. So with our in-browser Python engine, again, they can do these exercises without having to go out to a locally installed development environment. You can see in this particular example, we've started the students off with some comments, so they would come in here and actually type in the code to complete the exercises. Now when they're done, they can click Run Code to see the results. If they get a little bit stuck, they've got a hint. They can see a hint there. And if they're completely stuck, they can show the actual solution. So here's a suggested solution for the activity. I'm going to go ahead and copy it over here, and we'll just paste it in and run the code. And you can see the expected output here. So again, this is a very powerful way for students to quickly and easily become familiar with the concepts and practice them right there in the web browser. So this is our Python in-browser coding engine, and this will work not only for Python, but we are actually going to introduce this for our other courses as well. So in the future, you'll see these sorts of things cropping up in our C# and Java and some of our other classes. Okay, let's go take a look at one of the graded activities from the student perspective. You'll find the activity instructions here, and then they'll click on the activity to actually get to work. Let's take a quick peek at the activity instructions. Each activity will describe exactly what the student needs to do, as well as showing one or more examples of the expected results. In addition, the activities will clearly display the activity rubric, with points assigned to particular things found either in the source code or in the printed output. And that's how our system will automatically calculate the grade. So when students are actually completing the work, they'll want to keep this rubric and the expected output in mind as they build and run their own code. Now to reach the activity editor, we'll go ahead and click on the activity link from the table of contents. Okay, this is our submission platform for Python programs. You can see the students have an edit tab, and this is where they would actually type in their source code. So in this particular activity, we asked the student to put a comment in their program and then print out several lines that demonstrated their class schedule. Okay, I've just copied in a few lines of code, and these lines of code will meet some, but not all of the activity instructions. The student can save their code and then run it with the little rocket icon. So again, similar to the in-browser activities, they can actually see the output code right here. And the students can repeat this pattern until they're confident their work meets the activity requirements. When they're ready to submit, they'll click over to Submission Status, and then just click the Submit button. Now when the submission is finished, the students will see a message that the activity has been submitted and it's awaiting teacher review. When you go back to the Edit tab, you'll see that the Save button is gone, so the students can't save new work after they've submitted to you as the teacher. This submission status panel will show them when you finalize the grade. So let's switch over to the teacher side and see how it looks from a teacher's perspective. Okay, we're now logged in as a teacher, and you can see all of the hidden links that are invisible to the student. We'll go ahead and click on the activity again. And a teacher will have a somewhat different view. You can see a list of all the submissions here, and you can filter these. You can look at all students in the class. Some of them haven't submitted anything yet, or you can focus just on the submissions. Now Charlie's student is a student from whom we just submitted that project, and you can see right now he has a proposed grade of 82 out of 100. So let's click on the grade button, and this pop-up will give you some more detail. You can see all of the tests that were run in the middle, the ones that passed as well as the ones that failed with the expected input and output. You can also look at the student code down here just to take a peek at it. So this is your opportunity as a teacher, if you want to modify the recommended system grade of 82. You might decide the student deserves more credit for some reason, or you might look at the work and decide that it merits some different grade for any reason that you choose. So once you're done, just click Save Grade. And that changes from a proposed grade to a finalized grade of 82 that shows up in the student gradebook. Let's switch back over to the student view very quickly. You'll remember the student view was looking at a message that says the activity was awaiting teacher review. So once you have finalized that grade, when the student comes back in, they will actually see their grade as well as the assessment report. Now what happens if you want the student to be able to resubmit this project for a new grade? Back over here on the teacher interface, you can click the Revise button and then simply remove this grade. Okay, the grade has been removed. The student must submit again to get new code in for grading. And you can see the grade is gone here, and it's gone in the grade book as well. Back over on the student side, if the grade has been removed, the submission status changes again, and the student has the ability to edit their file once again, to save changes, and then submit it for a new grade. Let's add a fifth line that should impact our grade. We'll save it. We'll come over here and submit it again. Great, you can see that proposed grade is now 100%, and you can go ahead and approve that. So that's how easy it is to grade student projects. The system will automatically assign a proposed grade. You can review and approve those grades with a few clicks of a button. And then if you want the student to resubmit, you can remove their original grade and allow them to submit new work. There is one last thing I want to point out. You may well want your students to work outside of the CompuScholar system and write Python programs on their own, on their local computer. And we do provide instructions for doing that in a supplemental chapter. So let's scroll down to the bottom of the course and click on Supplemental Chapter 1, Python on your computer. And this chapter has 3 important lessons that will enable students to work locally on their own computer. And again, you might want to do this simply because the student wants to write creative programs on their own, or you may wish to assign additional projects outside of the CompuScholar graded system, or you may simply want to bypass our auto-graded system altogether and have students do assignments on their own. So whatever the reason, students can come in here and learn how to do Python on their own. So lesson 1 is all about installing Python. And if you come in here, you'll find some warnings and notes about versions, as well as installation instructions for Windows and Mac OS. Python installation is free and requires no registration. The next lesson is all about managing your project directories and Python source files. So we talk a little bit about the file system on your computer, how files are organized into folders. We talk about file extensions and how to view them on your computer. We recommend creating a root project folder and then storing your projects in subfolders underneath that project folder. We briefly talk about using Windows File Explorer, Mac OS Finder, and that sort of thing. So again, when students are creating files on their own computer, if they're planning on submitting them to you for a grade, then you would need to work with your students to specify exactly how they're going to do that. And then lastly, we have a lesson on using the Python built-in development environment. The Python development environment is called IDLE, I-D-L-E. You can find that from your Windows Start menu or your Mac Applications folder. And it's got a pretty straightforward interface where you can do things from the command line. You can also create and edit source files and then run those programs and see your output directly in the IDE. So again, this lets you build and run Python code without actually needing command line access. So this lesson will show students how to do that, how to handle basic error messages, and that sort of thing. So these 3 lessons combined should be all that you need in order to enable students to do work on their own computers outside of the CompuScholar ecosystem, either on lab computers or on their own at home. So that is a very quick tour of the new features in our Python programming course. If you want to take a closer look yourself as a teacher, of course you can contact us through the normal channels. We have our Getting Started links on our main website. So teachers at schools can always request a review login. We really appreciate your time today. Thank you so much for watching. Again, you're welcome to contact us with questions. You can email me directly at chris.ust@compuscholar.com or give us a call or contact us through our website.